ああ、疲れた。Excuse me. See. How's how's life? Let's see. Where was I? I don't remember what page I was on. Oh, that's a new one. Who's that? I guess I have to. That's one thing that's annoying about Restream. I can't see the emote information. Who is that? OB Katie Cat? Is that... How do you read this name? Hmm. Coming out the other. Yeah, you know it. What'd you have today? Yeah. Oh, actually, speaking of spicy food, I had one of those that Vietnamese sandwich. You know, it's like on a baguette, and it's got like it's usually like pork or chicken inside. What is that stuff called? Um, but um, but they always put like a pepper in the sandwich, and it's it's always the sandwich is good, and I think the pepper is a good touch. It's just since the pepper isn't chopped up, or they give you a slice, but they don't like dice the slice. So when you're eating the sandwich, it's like you're eating it normally, and then all of a sudden there's all this spiciness, and so so yeah. So that happened at lunch today, but I don't think it's. But you know, in the grand scheme of things, like that spiciness hurts for a little bit, but you know, after like maybe half an hour, it goes away. So it's not actually that bad. Um, Ghost pepper hot sauce. Oh, geez, yeah, that doesn't sound fun. That doesn't sound fun. Why would you do that to yourself, man? I mean, I guess if you say so. Yeah, if you say so. Actually, throw my. Oh wait, did I clock out today? Sorry, let me just make sure I actually clocked out. I mean, I guess technically I could clock all these hours that I'm streaming, but um, I'm only authorized for 20 hours a week, so yeah. No, I actually I didn't even clock in today because otherwise I'd go over 20. But Anyone streaming today? Yeah, I don't think I can. I've heard how, I've heard ghost peppers can be pretty bad. So I mean bad as in like spicy, not bad as in well, so the thing is, honestly, I'm kind of curious, um, because I heard that with like the really extremely like spicy peppers, that there's like a, what do you call it? I don't know, but like there is supposed to be some like depth to it. So I am curious what that tastes like, but I'm also not um in the mood to totally mess up my digestive system for, several days. So I'm not really in the position where I'm comfortable doing that. So yeah. Although I guess they have also those. I know there's like potato, like single packs, like individually packed potato chips that are like that are like ghost pepper flavored or something. So I I am curious about those things, but I don't know if I could necessarily, make the plunge or take the plunge to try it. I guess Crony's singing, so we can play. What song is this? Anatani Anatani. What is this? What is this? This is Kanadia. Oh, whatever. I should be focusing on studying. Uh, anyway. Um, yeah, okay, let's do this example again. I keep losing my pens. Anyway. Okay, so they say as a simple example, they use ray optics. Consider a 35mm camera to take an artistic head and shoulders portrait for a friend. For portraits, the most pleasing perspective occurs with a camera to subject distance of a few feet, 4 feet being about optimal. Okay. So, camera to subject. So we'll draw a little camera. I guess a camera doesn't look like this anymore. Camera and subject. Cool. This is 4 feet. Hmm. They say the film frame is 24 by 36 millimeters in size, and the outline of a human head and shoulders about 400 by 500. Thus, the desired magnification is 24 over 400, or 0.06. So I mean, is that just like a piece of side information? So we say that we want 0.06x magnification, which if anything is we want to shrink the image, but calling it, you know, like decimal magnification, I guess. So I think that sits in a separate little piece, and then I don't really consider that. Then a little difficulty focus with the music on. Is anyone just streaming, like chatting? Do not streaming at 1 a.m.デルさんの配信見るか。久しぶりに。Here, that's something to watch. Okay. And then I mean, I guess the image that I wanted to draw was like you have the person, and then, I mean, the diagram that I wanted to draw was like, okay, and then you send it through a lens, and actually, wait, no, now I think about it, how does that work? Because you'd need two lenses, right? If you send a collimated beam into a lens, it should converge, and or diverge, and then you'd need another lens to diverge and recollimate it. So, and then isn't that what makes the image smaller? And it doesn't seem like they use any diagrams, right? They just kind of do this manipulation to say we have f equals, sorry. So, okay, so if we take this diagram for granted, like the behavior of a lens, or a lens, this is that. This is the optical axis, and then the object is up here. And I guess these are this is the light kind of coming off of it and then going through the lens, and the focus would be right here in that case, right? And then this say D O D I, this is the image, this is the object. And they just say very simply that magnification M equals DI over DO, which makes sense. And then likewise, if we say that the focal length is this, how is that determined? Oh, I guess that's just determined when this upper beam, so the beam parallel to the lens, hits the, or gets deflect or gets um, warped and hits the optical axis. So that corresponds to this guy, or I guess it could correspond to this guy. These I guess should be identical for a symmetric lens. Is then the focal length, and I guess they say that how do they get inverse d naught plus inverse di equals inverse f? How do you get that geometrically? Whatever. So I guess they're saying, but if you were to combine those two, which I think is fair, I guess what they're saying is you could multiply. I can imagine it. So you eventually, I guess, work it out to f equals md naught over 1 plus m. And then the magnification is 0 0.06. So 1 plus 0 0.06. And we just need d object, so the distance from the object. And the focal point is I think that's what the 35 millimeter camera part is. I think that's 30, right? Isn't that what it is? The 35 millimeter camera has a lens with focus 35. Is that right? What does 35 millimeter camera mean? Describes a what is the let's see if lens is it what does the 35 millimeter mean? Is it the focal length, or is it yeah. Here's someone that at least corroborates that. So that's good. Hmm? I don't get 73.5 millimeters. Oh, I'm plugging. Excuse me. I'm plugging into the wrong part. Sorry. No, it's 35 equals 0.06 d naught over, or do plus 1.06. Okay, so 1.06 times 35 divided by 0.06 should give d. Oh, okay. That seems like it should be a really big number, though. Yeah, that doesn't... Is this equation really right? 1 plus magnification is in the denominator, so I want to bring that out. So that's 1.06. And then the focal length of the lens is 35. So that goes there. So the magnification times the D object. Actually, wait. So it says here, yeah, we are trying to find the focal length. So leaving F unsolved was okay. Right, we wanted to find the focal length of the lens that we need. And they say camera to subject distance, which isn't DO, that's DO minus DI. But I guess it's something to the tune of 4 feet. Okay. Oh, wait. It's camera to subject distance. So we are given the distance from the lens effectively to the subject. And then that should be 1.3 meters. Okay. So then it's m times, so 0.06 times the distance from the camera to the subject, which we're given as 1.3 meters, divided by then 1.06. This is in meters, so to get millimeters, we hit this by 1,000. 73 millimeters. Okay, there we go. I was getting mixed up. Okay. There we go. Okay, yes. So we can do basic math. Mission accomplished. Anyway. Anyway. We can associate a phase with each ray by calculating the phase shift of a plane wave traversing the same path. In doing this, we have to ignore the surface curvature in order that the plane or the wave remain plane. A shorthand for this is to add up the distances of the ray traverses in each medium and multiply by the appropriate values of k. Citation 22. Right, because the quantity k that we talked about earlier in in the description of a wave was called the I believe it was the propagation constant. Let me double check. So it makes sense that we use the propagation constant multiplied by the propagation distance, i.e. how far the ray slash wave travels, then to figure out how much phase it accumulates as it does that traversal. Now is that actually true? Is k actually considered the propagation constant? Yes, propagation constant. Okay, so lenses. In the wave picture, an ideal lens of focal length f transforms a plane wave e to the ik ux plus vy into a converging spherical wave whose center of curvature is at uf vf. Um, Again, where f is the focal length. It does so by inserting a spatially dependent phase delay due to propagation through the different thicknesses of glass. In the paraxial picture, this corresponds to a real space multiplication by... I have no idea how to read this notation. Mm. Ooh. These are round brackets.やべえ、眠くなってきた。うん Okay, yeah, I don't know what it's supposed to say, but whatever. So, example 1.4, a lens is a Fourier or transformer. As an example of how to use the Huygens, I guess, Huygens propagator with lenses, consider a general field theta x, y, negative f. Distance f behind a lens whose focal length is also f. The operators must be applied in the order the fields encounter them. Here, the order is free space propagation through f, followed by the lens's quadratic phase delay, as discussed by 1.33, equation 1.33. Another free space propagation through f. Using 1.23, 1.23, shit, 1.23, that's the Huygens integral, twice. The field, because you use the propagator twice, you get this disaster. Okay. Which is a pure scaled Fourier transform. Thus, a lens performs a Fourier transform between two planes at z equals plus minus f. Sure, okay. If we put two such lenses a distance 2f apart, as shown in figure 1.5, then the fields at the input plane are reproduced at the output plane, with a Fourier transform in between. That I think is fair, yeah. The image is inverted because we've applied two forward transformations instead of a forward followed by a reverse. So x or xy maps to negative x, negative y. This configuration is called a 4f relay. See section 9.3.12. If we put some partially transmitting mask at the transform plane, we're blocking some of the Fourier components of theta while allowing others to pass. Parentheses, a more general mask can apply attenuation and phase shifts as well. Mathematically, we are multiplying the Fourier transform of theta by the amplitude transmission coefficient of the mask, which is, I assume, kind of a fancy way of saying where does the mask let light through. But anyway, which is the same as convolving the image with the Fourier transform of the mask appropriately scaled. This operation is spatial filtering and is widely used. Okay. The Fourier transforming property of lenses is extremely useful in both theory and applications. Perhaps surprisingly, it is not limited to the paraxial case, as we will see it in section 9.3.6. I mean, I think that's definitely one interesting thing, which is we use plane wave assumptions a lot, but in spite of that, in practice, we can't really get a plane wave in the lab. So we have to use Gaussian beams or Gaussian waves. In spite of that, a lot of our intuition for plane waves seems to hold fairly well. Not maybe not all, of course, maybe not even a majority, but a good chunk of them. Like an understanding of plane waves and how they would behave is enough to kind of get, at least our experiment up and running. So. Oh, jag benni mig. Anyway. Sure. I mean, I don't really get what was said here, but whatever. Aperture, field angle, and stops. Of the rays entering an optical system, some will make it out the other side and some won't. Fair enough. At most locations in a system, there is no sharp boundary between the two groups. Okay. At a given point in space, light going in some directions will make it and that going other directions will not. Similarly, rays of a given angle in some places may make it and in other places not. What is the point? Each ray that fails to make it will wind up hitting some opaque surface. The surface that most limits the spatial field of a ray running parallel to the axis is called the field stop, and that which most limits the angular acceptance of a point lying on the axis, the aperture stop. I need a drink. Okay. Each ray that fails to make it will wind up hitting some opaque surface. The surface that most limits the spatial field of a ray running parallel to the axis is called the field stop, and that which most limits the angular acceptance of a point lying on the axis, the angular stop. I need a diagram. Hmm? Field stop versus an app. So let's try it one more time. Okay, so the surface that most limits the spatial field of a ray running parallel to the axis is called the field stop. The surface that most limits the spatial field of a ray running parallel to the axis. So sorry. So that's not. Let's see, so field stops. The field of view of an imaging system, i.e. the angular range in which objects can be imaged, is always limited by some kind of optical aperture, which is called the field stop. Different apertures can play that role. In a digital photo camera, the limited size of the image sensor usually limits the field of view. Light from more extreme angles might still get through the optical system, but would not hit the image sensor and therefore not contribute to the image. A field stop can also be a diaphragm, which is located in an intermediate image plane. Sometimes an optical aperture results from the construction of the instrument. If an optical system contains multiple apertures, the field stop is that aperture which most severely limits the field of view. Okay. Note that an optical aperture does not lead to sharp edges in the field of view. If it does not lie in a plane conjugate to the object plane. There is then some vignetting effect, i.e. a gradual decrease of image brightness at the edges. In a Keplerian telescope, for example, the field of view is limited by the ratio of the diameter of the ocular lens, essentially the barrel diameter, and the focal length of the objective. The field stop is then the barrel. As the barrel entrance is behind the intermediate image plane, there is some vignetting. So if an optical system contains multiple apertures, the field stop is the aperture which most severely limits the field of view. So I think that, well, then what is the importance of the beams being parallel then? Kate, welcome back. Yeah, it's actually not homework. I'm just kind of reading up on optics fundamentals because, well, A, I'm a little bit rusty on that, and B, well, I'm actually trying to get to something else later in this book, but I figured I should at least go through the intro properly. So yeah, that's what I'm doing. Well, I don't always want to be doing homework though. What is that? What is that like depressing lifestyle? Just forever. Is that like some special kind of like purgatory? Like there's always a homework assignment. Anyway. Secret template. Homework. Sorry, I don't actually know. Like I don't know what if there's what the layers to hell there are if they're I'm not really familiar, but yeah, sure, sure. Let's just leave it at let's sure, yeah, 10th layer, whatever. Yeah, it's it's right before it's right before that midterm that you forgot to study for, and yeah, uh, yeah. But no, it's a relief to not have to worry about exams and stuff anymore or studying. I can actually like sit down and admittedly it takes a while to read these textbooks but or these reference books and stuff, but at least I can actually kind of sit down and think about what I'm trying to study. So yeah, although admittedly I am getting kind of tired today. um and there's some other stuff I wanted to do today, so yeah, I feel like I'm forgetting about something though. I don't know. Well, anyway, yeah, no, today was a lot of I guess I didn't do necessarily a lot, but I did some soldering. I made a little photo detector to test out part of my circuit. Um, I figured I'd so one of these projects that I've been kind of perpetually working on is this differential photo detector. But I think I don't know if I mentioned before, but it has a lot of noise in it. Or it's awfully noisy, which is actually very strange because the noise doesn't seem to relate to the kind of the what do you call it, like the supply rails or anything. It only shows up when there's actively like photo, well, when there's actually like light going through the detector. When you just power it on and leave it on standby, there is no noise. So that somewhat already kind of says, hey, the noise isn't in the power supply rails or anything, which is helpful. But nonetheless, it's kind of strange in that we've already kind of troubleshooted a lot of the other possible reasons it could be noisy, and yeah, it's not quite clear to me. I think at some point I might just need to take the output of the detector and just shove it in a spectrum analyzer or some. Well, anyway, sorry. So that's this project that I was working on. So I was doing a little soldering to kind of sanity check a couple things, and then reading this also has to do with that detector because there later in this book it discusses more things like signal like detection like or detector like design practices and such. So it's all kind of related. Which is to say, I guess that I'm kind of at work. Hence why I'm at work. Some big brain learning. Well, it's pretty small brain because so that this is the thing. This project isn't supposed to be that hard. At least according to my PI, and from what I can tell online, this is not supposed to be hard like at all. Like this should have been done like a year ago, like several months after I started, and I should have just been done and started working on something else. We have like no fucking idea what the issue is, because we've already like so sorry. So just I guess some context might be more important or might be relevant, but this is a differential photo detector, right? So just as a reminder, the idea is that you send two beams of light into this detector. One is, or yeah, one is a reference beam. Or I guess, so what really happens is you have a light source, and you split that light source into two beams, two somewhat equal beams. The benefit of doing this is that when you eventually bring those two beams back together after they take their different paths, since they're the same beam, any like say laser noise, like say our light source, our laser like fluctuates a little bit, any noise will be shared between both beams, and then we can compare the two beams and then like subtract them from each other. So it's helpful to then to have our lasers be originating from the same device, right? So we have our laser, we send a beam out and we split it. first. One beam we keep as our reference, and then we eventually send it to the detector. The other goes through our experiment and then comes out. So eventually, when they come back together, they're different in that one is influenced by the experiment and one is not. But at least in terms of their noise, the noise that's attributed to purely the laser, like the light source, the thing that generates our laser, will be shared between the two beams. So if we can then take those two beams, after, again, after one has gone through the experiment and one is just saved, and we kind of subtract them from each other, then we can, it's very, you subtract them. So you subtract out the shared component, which is presumably the laser noise. So this is why we're using this differential detector, so that we can, or this differential detector. The idea is that the differential part is that we want the difference between the original beam and the one that goes through experiment. The shared component will be stuff pertaining to the laser noise, but the difference will be the part that the experiment influenced, and we only want the part that the experiment influenced, hence why we're using this differential photodetector. Anyway, so that's why we're using this specific setup. So what this detector does is, in addition to just kind of taking the difference, it also feeds back the difference, like the value that we read off that difference value as our measurement, but we also take a little bit where we also take that signal and we feed it back into our detector, so that the detector can, like, over long time periods, kind of even things out, or can average out. So there's a feedback loop that takes the signal and then uses it to kind of modulate the detect itself. And the thing we're trying to modulate is like constant offsets. So let's say the difference between our experiment, the beam that goes through our experiment, and our reference is like constantly equivalent to, it's laser light, so you can't really directly relate it to volts, but we, by sending it through a photo detector, we convert photons into electrons with some efficiency, right? So I'm gonna say volts, but really it's photons, and then that's related to some voltage or some electron, what do you call it, or some electric potential. But sometimes, it might just be like constantly 2 volts worth of photons or electrons that were converted from photons off. And that 2 volts is, that's cool to know, but, that's not really what we're interested in this case. So we wanted the ability to, like, average out constant offsets and only keep, like, sudden spikes. What we care about are the sudden spikes in like, light in the differences. Like, if there's a constant 2 or 3 volt difference, we don't care about that. So we have a feedback loop that takes that into account and says, okay, if there's a constant, like, say 2 volt offsets, then I want to, like, turn a little valve, so to speak, like an electric valve. It modulates a transistor, but the point is that the transistor is acting like a current, or like an electric, like, valve, in the same way like a water valve, and it kind of modulates how much you're feeding into the detector. And the end result is that over long periods of time, constant differences will be zeroed out, but sudden changes, like these sudden spikes, these sudden signals that we care about, are retained in, when we're reading off the detector. So what I was saying earlier is that when the detector is off, I don't see these weird noise spikes. Or when the detector is off, the noise profile looks exactly as we expect. However, when we actually have light running through the detector, then we suddenly see these very, very frequent but not consistent noise spikes, and they're very large. And it's not clear where they come from. Because the detector has no noise when it's off, it suggests that power supplies are fine, because if the power supply were causing the noise, then you would expect it to show up even, or you would expect these weird noise spikes to show up even if even if no light was running through the detector, right? So the fact that it doesn't show up when the detector is like on standby but just like totally blocked suggests that it's not a power supply issue. And I've done a few more tests to verify that. So then it seems like it has to do with this feedback part, or at least it seems like it might have to do with the laser itself, for example, or the photodiode, the thing that actually converts photons into electrons, right? So we've taken a look at that as well, but it still seems to show, like if I take out the photodiode and replace it with an equivalent component, one that isn't dependent on like the laser, for example, then we still see the noise, but it's a different kind of noise now. So it seems like it's somewhat related, but it's not totally related to the laser. So then, we were like, okay, well, we mentioned there was an electric valve that sort of modulates, or there was a valve that kind of modulates, not water, but, the flow of electrons. So we were like, okay, well, maybe that component is the one that's causing issues. So we've done things like putting it in like a metal box to shield it from radio frequency, noise and such, because, there's like Wi-Fi, there's your phone, there's a lot of things in the room that could potentially, cause interference with these components, and we've blocked it off from that. We still see the noise. So, and we've been kind of iterating through these, there's a couple other things we tried, but it's not clear why this keeps happening. So anyway, I've gotten to the point where, just kind of throwing darts at the wall and seeing what sticks in terms of troubleshooting isn't really working. So I cracked open this book and I was like, okay, maybe I just need to, really just go back to the fundamentals and see if there's anything I can like just, if anything just pops up. So hence why I'm reading. Of course, this is the intro of this book, so it's mainly optics focused because, well, the title of the book is literally Building Electro-Optical Systems. I can't talk today. Building Electro-Optical Systems. There we go. So we're in the optics part of it, but I think that's important too. Maybe there's something in the optics that I set up that was causing this noise, which would be strange because 3 separate individuals have observed this noise in the detector I've made, and they all had separate, like I made multiple units of these, and they all had separate units, and they all observed this issue. So I don't think it has to do with the optical system, but nonetheless, I think it's still worth going back through the fundamentals. So that's what I'm doing. And specifically, this section is discussing, I guess, field stops and aperture stops, which I don't quite understand. So let's see. So the book here says, the surface that most limits the spatial field of a ray running parallel to the axis is called the field stop. And that which most limits the angular acceptance of a point lying on the axis, the aperture stop. So to me, it sounds like the language used. Well, so the language used here, I guess, is saying the difference between the two terms, or what constitutes one of these stops, I guess, is whether you're judging parallel or angled beams or rays. So I guess the field stop is like if I guess if you have like a wall and like a hole cut in it, or you have multiple walls and multiple holes cut into it, and you're passing this just massive beam through the smallest hole, which, as borrowing the language from this book, the smallest hole would be, or the wall with the smallest hole would be the surface that most limits the spatial. So I'm assuming spatial is in like the plane of the of the wall, but the spatial field of a ray running parallel to the axis. So I'm assuming in that case, if you had like say consecutive walls with different size holes in it that are all concentric, then the smallest hole is the field stop, I guess. But then they say that which most limits the angular acceptance of a point lying on the axis is the aperture stop. And that's what I'm a little confused on. Like, how do we judge that? So do we just select a... So I'm wondering, like, is the concept of an aperture stop dependent on the point in question? Like if you had if you have your system and you have various points along the optical axis of your system, then does each one of those points have a different aperture stop, as they call it? Is that maybe I'm wondering, is that the right interpretation? Or now here's something I opened. So aperture and field stops. Stops determine the light collecting area and field of view of an optical system. I mean, that much I can somewhat understand. We can find the stops by tracing two rays called the marginal or axial ray and the chief or principal ray. The aperture stop limits the area over which light is collected. Okay, and the field stop limits the angle from which light is collected. That sounds like the opposite language to what this book is saying. I don't know. I don't get this stuff. You know, I think I've dumped enough time onto this topic. I'll think about it later. Let's move on and then we'll come back to it later. Okay. Let's see. As an aside, vignetting. Aperture and field are defined in terms of axial points and axial rays. There's no guarantee that the aperture and field are exactly the same for other points and other directions. Rays that get occluded somewhere other than the field, or aperture stops, are said to have been vignetted. Rays that are occluded somewhere other than the field or aperture stops. Okay. Vignetting isn't always bad. It's commonly used to get rid of badly aberrated rays that would degrade the image if they weren't intercepted. Better a dimmer image than a smeared out one. Interesting. Okay. Interesting. When a laser beam hits the edge of an aperture, this is also loosely termed vignetting, even when it does happen at one of the stops. Interesting. Okay, so just as a general term. Okay, that's fair. Fourier transform relations. Fourier transforms crop up all the time in imaging theory. Oh, my iPad just ran out of charge, didn't it? Okay. Fourier transforms crop up all the time in imaging theory. They're a common source of frustration. We forget the transform is a common function, or we forget the transform is a common function, or can't figure out how to scale it properly, and what was a tool becomes a roadblock. This is a pity because Fourier transforms are so powerful and intuitive once you have memorized a couple basic facts and a few theorems, apparently. In an effort to reduce this confusion, here are a few things to remember. Following Bracewell, who the fuck is Bracewell? We put the factors of 2 pi in the exponents and write g... What does this sideways u mean? Sideways U is pronounced a subset of. Where is my post-it? Okay, so following Bracewell, we put the factors of 2 pi in the exponents and write capital G is a subset of lowercase g, and capital G equals some Fourier transform of g for g as a transform g. Okay. So yeah. So they say it's customary to use lowercase in real space and uppercase in k space. Okay. So G is k space, or capital G is k space, and lowercase g is real space. Okay. A side benefit of this is that we work exclusively in units of cycles. And they say, note 23, in optical design, we use units of waves rather than cycles, but it's the same thing. Oh, okay, sure. Oh, okay. The pitfall. For a traveling wave in the positive direction, the x and t terms in the exponent have opposite signs. X and t terms in the exponent. Where is the t term? Oh, whatever. So they say it's easy to get mixed up with forward and inverse directions, and they also note that physicists and I can't talk. Physicists and electrical engineers typically use opposite sign conventions. Wow. Where have I seen that before? Maybe in the frickin' spherical coordinate, designation or, setup between physics and math. Yeah. And I'm noticing a pattern here, and it's not the math people or the electrical engineers. Anyway. Let's say useful functions. The Heaviside unit step function u of x is 0 for x less than 0 and 1 for x greater than 0. The derivative of u of x is the Dirac delta function, delta of x. Sinc and what is a jink function? Functions come up in connection with uniform beams. What is a jink function? Jinc function. What is that? A sombrero function, sometimes called a Basinc function or a Jink function, is the two-dimensional polar coordinate analog of the sinc function. Okay, sure. Let's write that down. Oh shit, I wrote it wrong. Oops. Okay. Even in odd impulse pairs, have transforms cosine pi x and I sine pi x, respectively. Okay. Conjugacy. Conjugate variables are those which appear multiplied together in the kernel of the Fourier transform, such as time in seconds and frequency in hertz. In optical Fourier transforms, the conjugate variables are x over lambda and u, which, as before, is the direction cosine of the plane wave component on the given surface, i.e., u equals kx over k. Convolution. A convolution is the mathematical description of what a filter does in real time or space domain, namely moving average. If g of x is a given data stream and h of x is the impulse response of a filter, for example, a Butterworth low-pass electrical filter with x standing for time, then hx times gx equals indefinite integral h of u g of x minus u du, which I guess somehow simplifies to, or which is I guess equivalent to indefinite integral g of u h of x minus u. Let's see. The second integral in what I just said is obtained by the transformation u transforms to x minus u. It shows that convolution is commutative. Thus, g convoluted with h is equal to h convoluted convolved. What is the? I don't know. Convoluted convolved. I don't know. Well, applying the convolution of g and h is commutative. The end. Okay. Oh, Monercy, welcome back. Yeah, how's it going? Remember we were talking about PS5 controller making up controllers per picking up controller sounds. Yeah. Although I guess you said that it somehow is able to cancel it or something. Or I don't know, maybe I don't know if it's cancellation or if it's oh, you have a clip. Let's take a look. Be like click. Yeah. You hear it? Oh, really? Okay. Well, let's take a look. See how good or bad it is. Desktop audio is off. Yeah. Oh, I see. Yeah, I guess you can hear it, can't you? I mean, I guess if the game audio is... Dude, aim a little higher, dude. There we go. There we go. There we go. Dude. Overkill much? But anyway. Yeah. Not the backseat game, but going for the oh I see. Okay. I was like oh right, wait, this is Dead Space, so you actually have to go for the limbs. Right, I forgot. Yeah. Do you hear yourself in the background? Honestly, it was kind of loud, so all I could hear was, I mean, the main thing I was hearing was just the game audio. Well, was I in the background? Is that like an Easter egg? Wait, are you just like passing my audio to your stream or something? Should I say like hi chat? I mean, I'm gonna be honest, dude. The game audio is so loud. I'm gonna be honest. If you can hear, I certainly can't. Uh, because I don't know. I certainly can't. Or maybe it's just I think the game audio is just too loud. I can't hear it. I can't. I mean, I mean, if you say I'm in there, I must be in there, but I can't hear it. That's for sure. Uh, Although what I did hear, which is a little concerning, is that apparently having difficulty hearing voices or identifying voices out of noise is apparently a sign of, or is apparently correlated to uh, getting dementia early. So, which is a little concerning because I really do have trouble listening to people when we're like out like in public and there's like, you know, a bunch of people around us like chatting. Like I regularly have issues with like listening to people or like hearing what they're saying. So that is a little concerning. Just thinking when they have scared. I mean, yeah, yeah. No, that's fair. That's fair. Yeah, I couldn't really hear myself though, so I don't know. Crappy live stream is a test. Yeah, but well, I mean, evidently it works well enough, right? How low quality it was. I mean, is that what due to like your streaming like bitrate, or let me see, is it really that bad quality? The audio, I feel like, you know, I don't know if it's just like a system volume adjustment that needs to happen, but it's already been encoded. Okay. Internet. Okay. Yeah, what, well, I mean, I assume it streams as best as it can. It does, although, so I feel like this happens a lot with Twitch clips, but I feel like the well, let's see. Yeah. I think it's fine, honestly. I mean, if anything, I feel like the takeaway from this is that even if you lowered the quality to like 480p, you could still kind of make out what's going on. So it's like, if anything, it means that maybe it's worth just streaming at 480p to just like, and then just having a more consistent image. I don't know. I don't know if you can choose that, but yeah. Yeah. I mean, of course, I say that, but also my stream must just look like trash as well because I'm streaming at 720 30 at like 2 kilobit or 2000 kilobits per second. So my stream probably looks like trash as well. I just figure since the screen's blurred anyway, it's like who cares if the resolute, who cares if the image quality is ass. Yeah. Well, the thing is that's because it's on your phone, right? Like, you know, if you were on like a 1080p like, you know, 24-inch screen or something, I bet the stream just looks like ass. I mean, I can test it right now. I can take a quick look. Well, it's not ass. It's just disappointing. It's not ass, it's disappointing. But part of the reason is there's so little movement on my stream that, you know, like a lot of the issue with these visual artifacts, right, is that there's compression going on. So the fact that the majority of my screen doesn't change from frame to frame just means, you know, just makes it that much easier to compress the data stream into, you know, whatever, you know, bit rate it needs to be. Look at all this. Yeah, it's Inception, man. But yeah. Anyway, yeah. Sounds. I mean, but yeah, like, I mean, I don't know. I feel like, so I remember when I first started streaming, we had talked, or I say we, but I don't know if I don't remember if you were there. I was talking about this where it's like, it seems like the conclusion I got from like a lot of the streams that I watched was essentially if your audio sounds like audio is probably like prioritizing audio makes more sense than prioritizing video. Both from a practical standpoint, it's not like you can just get a new ISP, but also from a viewer standpoint, like sure, it's not going to look super nice if you want to full screen the stream, but I feel like what often people do, at least in my case, or like or at least, yeah, I don't know, at least me personally, but also I feel like a lot of people do this, is they'll have the stream, but they'll definitely just like pull something up and be doing something else on the side. I feel like that's very common. And in that case, the image quality doesn't mean shit, but the audio quality becomes really important there, right? So so at that point, it's like, yeah, so the thing to optimize, both in terms of what is practical to optimize, but also what is more valuable to optimize, is really the audio. So as long as the audio is decent, I feel like you're good, man. Yeah. I'd like to, clean up my audio myself at some point, but yeah, we'll see. Eventually, sure. Yeah, eventually, by my standards, which is more like 3 years from now. But eventually, right? Like I eventually ended up, you know, adding this, right? So, uh, yeah. So I eventually added this thing, so this functionality. Um, So yeah, right, and that too. The drop, like all it was, it was literally just click a button in VTube Studio, but like I eventually added it, so it only took like a year, but yeah, it took a year to click a button, but anyway. So eventually I'll kind of off. Yeah, we're so high tech, man. We have we have collision. We have like collision boxes now. Holy shit, we're like halfway to a fighting game. Future. Anyway, yeah, yeah. Anyway, yeah. I'm actually not quite sure how the collision works. Like, what is it actually colliding on? I'm not quite sure, because I don't think. I mean, maybe it is just the bounding box for the each live 2D asset like component, but I'm not actually sure how it determines what it collides with. Let's test it again. I mean, feel free to. There we go. Yeah, right. Like it's not the edge though. It bounces part of the way through the head and then it hits the head. So it's not quite clear what it's colliding with. Yeah, I'm not sure. And I do wonder if I'm like moving around back and forth when you drop some like emotes, will it actually hit like sideways? Like will doing this knock one of the emotes to one side? I don't know. Yeah, not sure. Oh, it worked. It worked. It worked. I saw it. It worked. Okay, so that does happen. Good timing. Good timing. Yeah. Okay. So, but yeah, it's not clear what it collides on. I wonder how it chooses what to collide on. Yeah. Very strange. Yeah. Cool. I mean, I guess it's good to hear that Dead Space is entertaining you. Uh, one way or another. Yeah. I I did a lot of soldering and I did a lot of cable management today actually for our labs, so I'm honestly kind of pooped. Yeah. And what was I saying? So, the second integral is obtained by the transformation u transforms to x minus u, shows it comes commutative. Yeah, yeah. This makes things clearer. Since multiplication is commutative and associative, convolution must be 2. A lot of imaging operations involve convolutions between a point spread function, i.e. an impulse response, and the sample surface reflection coefficient, or the sample surface reflection or sample surface reflectance. This is either the coherent case or the incoherent case. I don't really know what that is, but okay. The Huygens propagator is also a convolution. I guess that's why we've been talking about it. One of the functions is flipped horizontally before the two are shifted, multiplied, and integrated. This apparently trivial point, in fact, has deep consequences for the phase information, as we'll see in a moment. The convolution theorem is also very useful for finding the transformation or the transform of function, which looks like what you want by cobbling together transforms that you know. Okay. By a change of variable in the Fourier integral, you can show that g of minus x is a subset, or sorry, no, that's an opposite subset of symbol. So it's saying that the case space g of negative f is a subset of g, the real space g of negative x. Sorry, what is this? Oh. Yeah, actually, this is a good way to see how the image quality is. Yeah, since most of the screen doesn't change, the compression isn't immediately apparent. Actually, whenever I test it, usually you can see the compression show up on the Live 2D model the most, because it's hard to see on my image capture. Um, but the hair often you can see like compression artifacts if I move too fast. Okay. Yeah. Actually, that kind of, you know how we were talking about like listening to your own voice at one point? I mean, I guess that came up multiple times, but um it's kind of amazing. Like when I first started streaming, and I guess this wasn't even 3 years ago, this was actually, so when I first started streaming, I was actually and I didn't stream all that much, but I remember I streamed Battlefield Hardline, I remember. I only played the beta. But I remember I was streaming Battlefield Hardline, and there was such a dissonance between my own voice and then what you heard through the headphones. But like, it's kind of at the point now where like when I listen to that clip that you just clipped, it's basically how I hear myself. So it's kind of interesting that over time, I guess I just like naturally just, I guess, streaming, like this, I've kind of like naturally like tuned the voice in my head to the voice that comes out. So anyway, what I meant to say is that I imagine, it, like it's I don't know if you're still worried about it, but if you are, then I think you'll probably just get used to it, honestly. Because like, is it really a bad voice thing, or it's just not what you imagine? Because I feel like often it's just not what you imagine. I mean, there are times when my voice kind of sounds like, I don't like how I sound, but often that's either because like my nose is kind of stuffy, And but like if you just kind of like take good posture and then you just kind of like speak with, you know, reasonable and a reasonable amount of like intent, I feel like most people's voices sound pretty, you know, what do you call it? Maybe not pleasant to listen to, but at least it's not unpleasant to listen to, right? Which I think again from an evolutionary standpoint kind of makes a lot of sense, right? Like we need to communicate. So a what do you call it? A vocal tract structure that produces a relatively, well, a not unpleasant, you know, voice is preferable. So it makes sense that, you know, kind of converge to something that's at least acceptable to listen to, right? So yeah, not what you meant. Yeah, and again, I think that it makes a lot of sense, right? Because like when you listen to your own voice normally, you're not just listening to the sound out of your mouth kind of reaching your ear backwards, but you also hear like the inside of your head vibrating, right, as you're speaking. So from what I understand, that should add like low frequency noise, or not no, or it should add low frequencies to the voice that you imagine. So I don't know if this is true for you, but what I was told was that the voice in your head, or the voice that you hear when you hear yourself speaking, is often uh, deeper, although it's not actually deeper. It's just it has lower frequency components that aren't necessarily present when you listen back to it through headphones, because you don't get the benefit of your voice vibrating through your head to get to your ears. Which for me was definitely true. It definitely sounds like there's like a low frequency, like not like bassiness, but there's like a heavy part that's missing when I listen to it through headphones. Um, but also I think this is again one of those things where once you get used to it, you can kind of isolate that low frequency part from the high frequent or the higher frequency parts and be like, okay, yeah, that's what I sound like. So yeah, don't sound like a skeleton NPC. Exactly. Especially like I think posture is a good thing, important thing, because if I sit like this, it's pretty hard to speak without getting like super like nasally. So posture is definitely an important thing. I say as I sit in this super uncomfortably positioned chair. The chair itself is comfortable. It's just it's a little low. Um anyway. Yeah. Yeah, but it's good to hear that Dead Space is doing good. Uh, okay, so they say by change of variable, you can show that the k-space g of negative f is a subset of g of negative x. That g, I guess, what does the star mean again? Like g star is the what is the word for it? It's when you multiply all the I components by -1. Stars uh what does star mean? No, I don't mean multiplication. I mean the I mean I guess it is multiplication, but uh oops. See how long beat the game of string. Yeah, yeah, cool. Cool. Wait, so how long does anyone have like a number for how long the main campaign of Dead Space is on in the remake? I'm honest, I don't actually remember what it is in the original, but I would speculate it's the same, right? Each chapter feels like for okay. Well, I mean, I guess that's giving a lot of I mean, I guess that's value, right? If each chapter is interesting and it seems like it lasts forever, then you're getting a lot of value for your money, right? So, although that's, I suppose that begs the question: is that because is that value thanks to the remake, or because just the original game's pacing was good? Like, I don't know, or maybe not the pacing, but at least if the content density of the game was good. What is the word for that? Complex conjugate. That's the word. So I think it's G star here is the conjugate of G. Um, it's a 120 remaster. I wouldn't call it a remake, even though the graphics are completely fit. Oh, so it's okay. I see. Or like games phrase. Okay, okay, yeah. Well, that's good. That's good. I mean, I suppose in that sense, it's good that I didn't play the original then, because then I can just play the remaster or remake or whatever. No. So you'd say it's better than the GTA remakes. um, Although I do wonder if part of the reason why those are easier to do, or it might be, or I do wonder if it's maybe easier to do like, uh, like Xbox 360 games, like, hmm? Am I back? Something lagged out there. Uh, Strange. Anyway, um, yeah, I do wonder if it's easier to do it on 360 back. Okay, yeah. Sorry, I don't know what happened. There was a big network. I don't know. At the very least, OBS wasn't able to send data, so I'm assuming there was a little bit of a network interruption. Uh, but yeah, I was gonna say, I do wonder if it's easier to do, or like I wonder if like I don't know what they had to go through to make the remake, but I wonder if it's easier to do on newer, or do remakes of newer games than older ones, just because A, I assume the source code is probably preserved better, and B, at least if it was primarily developed for, like, say, Xbox, then the hardware architecture is much closer, right? Like if it was designed for, say, PS3 or PS2 or something, or like older consoles, then the target hardware is further and further from modern hardware, right? But the Xbox 360, from what I understand, and even the original Xbox, but especially so with the Xbox 360, from what I understand, used pretty hardware pretty close to computer hardware, right? In the same way that the Xbox One, and I guess, well, both the PlayStation and the Xbox One, or sorry, not Xbox One, Xbox Series and PlayStation 5, from what I understand, use AMD X64 hardware with like RDNA 2 graphics, but like each modified slightly. But the actual hardware is much closer to computer hardware than, ever before. So I do wonder if maybe those kind of factors make it easier to develop like a good remake, as opposed to, hey, let's just dump a smoothing filter over everything and call it a day. um Because if from what I understand, I think like it wasn't the old Xbox like a power P isn't like the first Xbox like power PC based or something? No, no, the original Xbox actually does use a Pentium 3. So that is basically computer hardware. Yeah. But yeah, so I don't know. Maybe the biggest differentiator is the fact, and yeah, it uses even NVIDIA GeForce graphics for the original Xbox. So I do wonder, what was the PlayStation 2? Was that like a MIPS? What is the architecture? Hardware. Uh, is an R5900 based Emotion engine. Oh, it's some, but what is? It's something like totally fucking custom, I guess. I see. So it's okay, but the CPU is a RISC processor of some kind. It's based on the MIPS R5900. I see. Okay, okay. So all the more why I would expect something like the PlayStation 2, like a PlayStation 2 game to be harder to remake because the hardware is like totally different and it's super old, so source code could have been lost. Um, PlayStation 3 a lot or very much so as well because I think that used also a custom, not a custom processor, but if I remember correctly, the processor for the PS3 was some like joint thing between like Sony and Toshiba, I think, and oh, here it says Sony, Toshiba, IBM. Yeah. Um, so it's some custom thing that, from what I remember, is notorious for being difficult to optimize. So it kind of makes sense why it might be easier to do Dead Space because it is newer and it was launched on Windows and Xbox. So architecturally it's very close, or it's not very close, but I presume it's much closer than say a PlayStation 2 game or PlayStation 3 game, right? So um yeah. Of course, at some point you go far back enough and you get to like, GameCube era or like Wii era, or not, sorry, GameCube era or like, Nintendo 64 era games, and you get to the point where like, you can just emulate the entire fucking processor and still be okay. So, yeah, going for remakes. It's on one hand, I'm like, oh, that's such a, what do you call it, half-assed way of getting, cheap like money, just going for the nostalgia. Um, on the other hand, like it is cool that, like these games that you kind of, you go back and play them and they're fun, but they're not, visually what you remember them to be because, your mind filled a lot of the gaps and made things cooler. But now the technology exists to like actually make the games as cool as we remember, right? So on one hand, while I'm like, this is clearly just a shitty cash grab, maybe not a shitty cash grab, but this is like a very like lazy cash grab, at least on the parts of the, on the people who, propose these projects. Not that the developers are half-assed, but whoever proposed the idea, unless they had something really important to do, it's a very like, oh, let's just release an IP that we already have, right? Like, oh, great. Anyway, but at the same time, it's like they, if they make it really cool though, yeah, must be reimagining rather than one-to-one copy. I think it's worth having a one-to-one copy, and I think the biggest example is like Resident Evil, the Resident Evil remakes. I feel like those, like, they gotta have the clunky controls. I feel like Resident Evil needs to have the clunky controls, at least the old ones. Like that's part of what made the game, right? Um so I feel like clunky controls. So that's part of keeping. That's partially what I mean by keeping. Why I'm saying there's value in a one-to-one copy. But different. Oh, right. But I just mean at least in regards to like I think there is room for just a one-to-one copy, but I guess what I mean to say is that um well I don't know. I guess what I mean to say is I would, if they're gonna remake a game, I would like it to retain the character of the original game. Like I think there's parts that definitely. Oh, I think one good example is isn't there like a GoldenEye remake now? Um, but from I read a review of the GoldenEye remakes, and apparently, they're like one of the things for the remakes that got changed was, I think the Xbox, the one that's on the Xbox, I think actually has like dual joystick controls now, even though the original game didn't. And I do want, like, part of me wonders, well, that kind of gets rid of the character of the game, but it is also kind of an accessibility improvement or like a ergonomic improvement in some sense. So it's like, I don't know. Um, but I think there's, I guess here's what I have to say. If the developers have no good idea of what they want to do with the remake, then I think a straight one-to-one with just better graphics is fine. Like, don't expect any praise, but you know, it's better than just like butchering it, right? Like if they're gonna do a remake and a reimagining, then they better like fucking like shoot for the stars, right? But if they can't do that, then I feel like they should just stick to like a shitty one-to-one remake or one-to-one, what do you call it? Like just like a copy but visual with like visual revamps or like control revamps, right? Like if they don't have the ambition to like really just like just again, as you said, do like a reimagining, then I do think it's fair to just stick to like just a basic like, you know, basic visual and control upgrade or control system upgrade, right? I think that's fine. And I think the biggest example is like the Mega Man Battle Network remakes that are coming out soon. They, I think, did just enough, or I think they're gonna do just enough, which basically is you have to buy two packages, but you get all the old games and you get online multiplayer now, and amongst other things. But I think really that's all they needed to do. So they could be really ambitious and go further, but I think it's fine to just be like, okay, you get all the mainline games and online multiplayer and some other features. Cool. And it's like, that's it. And I'm like, they could do more. They could give us the the spin-off DS games and so on and so forth, and all that jazz. But in terms of like bare minimum, I feel like they've at least announced the bare minimum, which is really just release the original games and then give us online multiplayer. I think that's all they needed to do, and they at least did that. So it's like, fair enough, fair enough. Don't expect me to buy a lot of copies, but I'll buy one. Um, yeah. Yeah, again, I think it's an ambition thing. I really think it's an ambition thing. If they have the ambition, then I think you're totally right. Because at least no matter how badly the remake fails, you can at least say that they did something worth trying, right? Maybe it doesn't work out well, but oh, Chitib, welcome back. But yeah, you know what I mean? Like, so I agree. If the developer has the ambition, then by all means, like do like just like tell the story that you want to tell, right? I think that's really what it comes down to. Like if they have that ambition, they should do that. But I don't think Capcom gives, or I don't think Capcom pays their devs enough to be ambitious, to be honest. Like I'm gonna be honest, I haven't heard a lot of good things about Capcom like work environments recently, so at the very least from Capcom I don't have that high of hopes. Yeah. 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 And like I think the same thing goes with like say, so like in my case I'm like like the Yu-Gi-Oh, like Yu-Gi-Oh Master Duel, the online one. Like I don't really think they did anything all that ambitious. but they did, I think, just the minimum they needed for the game to be successful. And I think it is successful. I mean, I don't know financially how successful it is, but at least in terms of like mind share, I think that game is very successful because to this day I still see a lot of people actively playing it. Um, and it's interesting to see every few weeks some new, streamer pick up the game. It's like, Yu-Gi-Oh is such a hard to approach card game that like, I honestly thought it was just going to keep kind of dying out over time, but it keeps on chugging, and I guess it's kind of it seems like it's on an upward streak in spite of the fact that the anime no longer uses the what do you call it, the regular Yu-Gi-Oh rules. It uses like, like kitty version rules, uh sort of, but not sort of. I actually like the new version. I actually like the Rush Duel format. Um, but the original format, they don't even use that format in in the anime anymore, so they don't get advertisement through that, or it doesn't really advertise the original. No, so I agree. I like the new, so the new format, the kitty version, so to speak, is called Rush Duel, or I guess you could call it Rush format, and it really matches the name. Like regular Yu-Gi-Oh is fast, but it's also, hey, I'm gonna play a bunch of cards turn one, set up an unbeatable board. You don't get to play the game, I win. Is basically how like modern Yu-Gi-Oh works. Um, so so Rush so the Rush format is very nice because um, well, there's like you can do a bunch of things, but it really does force the opponent, or it does force you to give the opponent a chance. And the rules are set up so that the opponent really does get a good fighting chance. And if they totally wipe out your board that you set up, you also get a fighting chance, because the way Rush Duel works is that your hand, right, your set of the 5 cards in your hand get replenished every turn, like fully. So if you use up all 5 cards and then, you end your turn, it goes to your opponent's turn and then it comes back to you, you draw 5 new cards. You draw so that your hand always ends up at 5 at the beginning of your turn. So you can see how very fast paced the game would be, right? Because you're encouraged to use up your entire hand so that when your turn comes around again, you can draw a bunch of cards and then, play all those cards. So it's a really, I think it's a really good idea, in spite of there people have a lot of criticisms about it. But I actually think it's a good, it's like as a format, I think it's really good. Yeah. Right? Like it's not this whole single draw thing, right? Because yeah, like what if you play all your cards, you have your blue eyes white dragon or whatever on the field, and you're like, ha, there's no way they can beat this. And then you've passed the turn and your opponent's like, yeah, that's what you thought. I draw. And then they wipe out your field, which is really, satisfying for the opponent, right? But now you're like, shit, I have no cards in my hand. They've got this big ass boss monster that beat my boss monster. But then what do? If you just draw 1 card, you're fucked, right? What's the point in continuing? Might as well just like forfeit the match. But the Rush Duel format, or the Rush format, is now such that once it comes back to your turn, it's like, oh, I have no cards in my hand, but now I have 5, right? I have a bunch of options to work with, right? So right. It doesn't. Well, it encourages you to yeah, right. It encourages, and it's actually kind of interesting because it also comes into play in a deck building perspective too, right? You're also encouraged when you build your deck to choose cards and choose ratios of cards such that you don't end up with a bunch of like dead cards in your hand, right? So it's very interesting how it influences not just the active gameplay, but just like pre-gameplay, like deck building, right? Which I guess is maybe natural for a card game, but nonetheless, it has a lot of implications in just the overall game, and I think it really makes it an interesting format. It's, at least for me, it's very interesting to watch people play Rush Duel because it's not too complicated. The game is fast, but it's not fast in the sense that it ends in 1 turn, but it's fast in the sense that there is a back and forth that does happen, or at least initially. I think these days the game's starting to get some power creep, but anyway. So it's much more approachable than Yu-Gi-Oh, where you're like, oh, I have to build my 40 card combo deck with like, I gotta have like 9 combo starters and like, like 6 extenders, and I have to, set up my extra deck. There's a thing called a fucking extra deck in Yu-Gi-Oh. But anyway, you have your deck and then you have your extra deck. As if that weren't annoying enough. And, depending on where you like, there's cards that like, return stuff from your field to your deck or your hand, right? But it's annoying because, because it's like, where does your card go? To your deck or your extra deck? There is a rule for that. But then you have pendulum monsters in Yu-Gi-Oh, which you think, you play, they come from your deck at the beginning. So you think, oh, if you return it, they go back to the deck. But they're weird because if you destroy a pendulum monster, it actually fucking goes to the extra deck. So now you got all this crap going on. It's such a complicated game now. But anyway, but my point is like, this is all to go back and say that Master Duel, which is the online version of the original or the main Yu-Gi-Oh rule set or format, is still chugging along, and it still seems like it's pretty popular. So it's like, and all they really did was they just implemented the cards, gave it gacha. They keep it as up to date as possible, and then once in a while they have like a special event where you're restricted to certain cards or something. And like in some sense that is kind of a cheap cash grab, right? Because it makes everyone that owns physical Yu-Gi-Oh cards just buy cards again. Just you're buying virtual cards now. So in some sense it's a pretty obvious cash grab, but like it's also just enough to be like actually good. So it's like, by all means, they didn't do anything really ambitious. Actually, they did some interesting things because they actually have a story mode in Master Duel that kind of goes through the card lore. So that's actually, I think, a really good addition. But my point is like they didn't go super ambitious with Master Duel. They're just like, I think they added just enough to make it really interesting. So you know, and I think this isn't to belittle the devs' work. I realize these are all like even just a basic cash grab still requires, I understand, requires a lot of development like hours, but but this is all just to get to the point that like I I'm understanding of, and I think in practice I can see why, and I'm in a lot of cases I might prefer just a basic remake. But if the dev really has that ambition, then yes, totally. Like shoot for the stars, and even if you fucking blow up on the freaking launch pad, it's still at least it's an explosion, right? At least you get the aesthetics of an explosion, right? Like so. But I don't know. I feel like there aren't that many devs like that these days, are there? I don't know. I feel like the main like there's been so much like movement away from like AAA like I feel like the more like left on launch date. But no, like seriously, right? Like what is what like AAA studio still has like its original talent, right? Like like Blizzard lost a fuck ton of its like talent in the past maybe like 5 years, right? Um I want to say most of the COD like from what I understand, right? Like they went to Respawn, right? So a lot of the COD like like the really good COD devs went to do Respawn, made Titanfall, and now they're working on Apex, right? So they're just not available for something like that, or for like a like what I mean, like this is kind of what I'm getting at. Like I feel like all the big names that are still in the business have either just gone to do their own thing, or they don't work at the original studio anymore. So it's like who could pull off like an ambitious like reimagining type like total just rethinking of the franchise type remake. Like I don't know, honestly. Like Kojima's gone, right? Kojima's not even at Capcom anymore. I think that's probably better for him. And I guess he did great with like Death Stranding, right? Although I haven't played that game, but it's like, yeah, who's left, right? Like it's all just fucking cash grabs, man. It's sad, honestly. I don't know. No, I mean there might be someone, but welcome to current. Yeah, I mean that's the thing, right? That's what it feels like. So it's like, and someone was talking about this, but like it's really it's really probably like generational knowledge just being lost, right? You never had the senior devs never had a chance to train the junior devs. So now that all of the big wigs, or sorry, now that all the big, original devs are gone, you have this like little kind of, this kind of vacuum, so to speak, that needs to be filled. But all the while, corporate wants the next big thing, right? So yeah, I don't know. It's yeah. And actually, this is why I was really disappointed with Battlefield 42. I thought Battlefield 42 was going to be really good. Um, but I just watched the gameplay and I was just like, holy shit, this game sucks. Like it doesn't look fun. I don't know what the issue is really, but like I heard it's getting better, but I still watch like Jack Frags is a FPS YouTuber, but he, back in the day, right? He was, if you watched Battlefield 3 Let's Plays, then Jack Frags, right, was the guy you watched, and corporate got to figure it out. I mean, or they could just fire a bunch of people and pad their bonuses for the year. I guess, and that's probably what they're gonna do. Um, but like, yeah, like Battlefield 42 was so hype, man. Battlefield 42 was so fucking hype, and like man, it's like people are saying should be better, but like, or then it's getting better. People have said it's getting better, and I'm willing to look at it again. But also like every yeah, right. Like, and so apparently they're bringing back like the class system because they took that out and stuff. So again, I'm willing to give it a shot. Um, or I'm willing to at least watch some gameplay, see if it's actually fun. But I'm gonna be honest. Like I saw some gameplay like a month ago or so, or several weeks ago. So I assume it's about a month ago. Let's just say several weeks ago, and it still doesn't look all that fun. It's like aesthetically, I feel like it's like it still feels like a step back. The you know the it just doesn't look fun to like I feel like part of the Battlefield games is like it's got to be fun to like run around, you know like obviously it's an FPS, so you got to shoot people, but like I feel like if it's not fun to like run around in the hills and like find a good spot and like like peek over and kind of do some scouting and then try to figure out where the enemies come, like it's got to be fun to like run around and like work around people or the enemy team and stuff, right? Like, and I didn't really feel that for 2042. So it was really really kind of or yeah, it was honestly disappointing on like at first when it came out, I was like, "Oh shit, it's so cool!" But I kept watching more gameplay, and I was like, "Wait, actually, this doesn't really look that interesting." Yeah, I don't know, man. Yeah, it's no, seriously. Because at first it was like, "Oh shit, people are doing like the freaking like the jet." Like jumping out of a jet and like shooting a missile at the person chasing your back shit, and like, oh, there's a zip line and all that crap. But like when I was watching the beta, I was like, wait, this is just like a clusterfuck. It's like you shoot one person, like three people like are coming from behind you, shoot you in the back. You don't get revives. You get stuck in the wall and you can't get revived. Or if you do revive, you fall below the map or like some shit like that. Um, you know the what do you call it? The vehicles don't look super fun to play. It's like it's just there's all these like and in some sense that's true, right? But like I feel like again, Battlefield, I think uh, uh, of course, what do I know, right? But at least from my super casual perspective, I feel like Battlefield 3 at least was fun to run around. It was fun to like run through buildings and try to find different, routes to get, or like, go through different routes to get to to the point. It's fun to like set up with like, you know, as an engineer, yeah. It was fun to just like set up your SMG like with the bipod on once you're on a point. You know, you got your medic like just dumping meds on you. You've got, you know, you get to just like pump ammo down onto the point while some other squad grabs it. You know, like or you know, like you know, like it's fun to like do all this shit. It was fun to like run around the map and like set up and try stuff and like, and you can still do that in 2042, but something just feels like boring about it. I don't know. And I think that's that generational knowledge. From what I've been told, the really like stellar like Battlefield game, like the best one was actually Bad Company 2, which was I believe before 3. But uh but what I think the issue is it it sounds like the people who did like the map designs for the for the prior games like left over time. So so now the original like super like rock like the guys who really knew how to do map design, they're all just gone from what I understand, or at least the majority of them are just gone. So like Battlefield 5. Okay, so I got something to say about Battlefield 5, or specifically about Battlefield 42. Is it just me, or does Battlefield 5 look like way better than 42 or 2042? Because I feel like I was like, where did all that, like, you know what I mean? Like how did the graphical quality like degrade over time? And I think this is that generational knowledge thing. Like I imagine whoever or whatever teams made Battlefield 5 and Battlefield 1 look like fantastic, like they must either just have been disbanded, or maybe they don't have the same staff anymore, or maybe they just left. I don't know, but like they're clearly not there, or they're not allowed to work to their, you know, to their best. It's like it's disappointing, you know? Like I was really looking forward to 2042. So, yeah. It just doesn't look fun. Like I don't know what they need to do, and I wouldn't mind if they just totally, and that's the thing, right? People were so, you know, focused on, oh, 2042, you know, they don't have classes anymore, and it's like I honestly don't care, right? Like I don't care if 2042 has or doesn't have classes. It just doesn't look fun. Like it just it's like, yeah, like I watch gameplay and I'm like, oh, okay, cool. There's a bunch of, you know, like there's stuff going on. There's a lot of stuff going on, to be quite honest. And you can do, there's very epic things, but like, you know, I watched maybe like 20 minutes of gameplay and I'm like, this doesn't motivate me to play the game at all. Like, you know, like sometimes there's some interesting moments, but they're very few and far between. And it's like, yeah, exactly. Like imagine having, and this is why the whole like NFT shit was like hilarious, right? Because the whole thing with NFTs, if I remember correctly, is like, oh, you can you can make money while playing video games, man. Imagine. And I'm like, I don't give a shit. Make it fun. I don't care if NFTs are in the game or not. In fact, fine, put NFTs if you want. Just make the damn game fun, honestly. And this is why, you know, people were like, oh, NFTs are a ripoff. I'm like, I don't care. I don't care if NFTs are a scam. If that's what they need to make money, then fine. Just make the damn game interesting, you know? Like I don't care. Like put in gotcha. You know, like so people had so many complaints about gotcha initially, right? I remember because I played Nexon games, you know? Like I played Nexon, I played Maple Story, I played Mabinogi the most, but like there was a fuck ton of gotcha in both those games. But like at least they were fun to play. Maple Story I wasn't that interested in, but like but Mabinogi was fun, which is why, like, okay, sure, you know, microtransactions are clearly, you know, predatory and whatever. Sure, whatever. I just have to, you know, manage my wallet. That's fine. But at least they made the game fun, you know? Not that not that paying made it fun, but rather the base game was fun, right? And I think isn't that why people are okay with, you know, uh what is it called? Not Azure Lane. Not Blue Protocol. What is the anime waifu shooter one? Blue Archive. There we go. Yeah, like that's why people are fine with Blue Archive. That's why people are fine with Arknights. That's why people are right. Yeah, like they're okay with those games and they have gotcha. But that's because, well, first of all, the gotcha is at least in what do you call it, Arknights. I know the gotcha is very well done, or the game balance is very well done. But like the base game is fun. Like, how do these corpos not understand that? The base game just needs to be fun. That's why Fortnite is so popular. It's not because microtransactions are fun. It's because the base Fortnite Battle Royale is fun. Like how do these corpos not understand that? Like that's all there is to it. Like I watched a fuck ton of Muselk playing Fortnite. I watched Laserbeam playing Fortnite. You know, I played a little bit. Although granted I had issues with my computer, which is why I wasn't able to play a lot, but I played a little bit of Fortnite in the past, which is more than, you know, a lot of other games. Like it just had to be fun. That's that like how do they not understand this? Like anyway. And yeah, so okay, you know what? I'm gonna call it a day. It's 10:30. I'm not getting any studying done. Well, I mean, I guess more like I did get studying done, but oh, hi. But I'm kind of getting tired, to be honest. uh, yeah, 10:30, right? Thank you. The rant. Yeah, no, it's just it's I don't know. This is why, you know, I don't feel motivated to like buy a game console, right? Because it's like, what fun games really are there? Like 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 okay, so Dead Space is, I guess, a remake that's fun, right? So there's that. But like there are, well, I mean there are a few, right? But like okay, so the other day, where's my iPad? Oh, it's charging. Um, just earlier today, I saw there was a post on Build a PC sales. Even though this isn't a PC, there's a post for a new PS5 at retail for $400. So, and you know, really that it begs that's the question, right? Are there enough games? I think say like 5 games would be enough. Let's say I buy 5 games at $60 a pop. That's $300 in games, and then 400, yeah, $400 for the game console. So do I really get $700 worth of entertainment, or will I get, you know, that much entertainment? I think with enough games you would, but it's actually 70. Well, shit. Okay, well, let's just call it a conservative estimate. But you know what I mean? Like it's hard to justify buying a game console. It's yeah. And I don't get how they don't understand this. It's like, why would I buy a game console? Like, sure, there's nostalgia and stuff, but like, I could just buy a, you know, I could just buy a used GameCube and play like Smash Brothers or something if I wanted to, really. Like, I feel like, yeah. I mean, part of it's inflation. Just emulate. Let's stay legal. Let's stay legal. I don't mind buying a used PS2. I can go to Super Potato in Japan and buy. Super Potato is a retro game store in Japan, but um I could go to Super Potato next time I go to Japan and get like a PS2 or something, I assume. I think they sell PS2s. Anyway, yeah, it's just like I don't know, man. It's yeah. And actually, so that's why people ask, like, you know, I sometimes I tell people I stream and they're like, "Oh, what games you play?" And I'm like, "What games are there to play?" I mean, there are a few. I have a massive backlog. But like I asked them like, "Yeah, what do you guys play?" And they're it's usually like Valorant or it's usually Valorant or League of Legends or again Fortnite or the new console game. And I'm like, "Okay." I don't know. It's there some of those are appealing enough, but it's like there's no game that really makes me want to just like install it immediately, like I haven't seen a gameplay like or gameplay that's made me think, okay, I gotta install this right now. I gotta play it this weekend, right? Like, yeah, yeah. Maybe I just need to get into like Candy Crush or something, something like uber casual. I don't know. Maybe I need to just like ease myself back into gaming. Let's play like, oh, Tetris. That's what I could play. Yeah. But anyway, it's I don't know. Get into Uncharted. Uncharted is Naughty Dog, right? The devs that's a Naughty Dog game. They also did The Last of Us, is that right? Yeah. I never played Uncharted, but I I'm familiar with The Last of Us, so I do recognize the title. Um yeah. Yeah, I mean, yeah, eventually. Eventually. I say eventually, but realistically, when the fuck is that gonna happen? So I think I mentioned this before, but timing wise, I really wish I could take like 2 years off of just everything school related, like research and school and everything related. Um, but also I just don't have the time to. So, but I would like to just take a year or two off and just like, play all the games I missed out on and like stuff like that and like build crap like like there's so many like things I want to try building, but what do you do, right? Yeah. And this is fun too, right? Like, building this detector is interesting and it's entertaining, but I do have to admit I've kind of hit a roadblock with this guy specifically, and like these optics and stuff are that I work on are interesting, but it would be nice to play a game at some point. And just I like the chatting. Well, yeah, I mean I suppose I should be chatting less, or I should be trying to chat less and less, but we'll see. I think it's fine because if as I mentioned before, right? If I wasn't streaming, I probably wasn't getting much done anyway, so it's fine. Yeah. Although actually, as a sanity check, the thing I was doing, was it yes? I don't know. Were you here? I can't remember. I was trying to do something yesterday about like calculating the Rayleigh range of something, and so one of my colleagues came by and we were chatting and I just mentioned I was going through this book and they were like, oh yeah, so you need some help? And I'm like, well, actually, yeah, I was having trouble calculating this Rayleigh range thing, and um, so he tried calculating it earlier, and he was like, yeah, I have no clue. I don't know how they've got their answer. So, so at the very least, a grad student also doesn't understand how the fuck to get the number 1260 lambda. So at the very least, I'm not the only one that doesn't understand. For what that's worth. Yeah, at the very least, I'm not the only one. Yeah, but anyway, yeah, yeah, I'm tired. I'm tired. I think I'm gonna call it a day. Yeah, so let's see, Monaristy and who else came by today? I think Kate was also here, and I'm pretty sure Skullmeat was also here. And I think that's it, right, for today? Yeah. Yeah. But yeah, Monaristy, thanks for popping by. Or I guess everyone, thanks for popping by. Take care, stay safe, have a good evening. I guess Monaristy specifically, good luck with more Dead Space, and I guess for everyone, I'll catch you guys. Oh, actually, one last minute thing. I gotta mention this as well, I'll keep mentioning this until then. But I have to head back to LA on the 11th. I will take my laptop with me, so I should be able to stream, but there'll probably be short streams in the evening or something. And then on the 18th, I head to. Can you in LA? I mean, well, actually, so oh no, never mind. I can't do that. Actually, never mind. Sorry. If I had next time I drive back I'm flying back to LA this time, but next time I drive back to LA, I actually have an idea for something. So it's not a meetup, but anyway, I gotta prep some hardware for it, so I'll let you know once those ideas sort out more. Meet down. Yeah, well, actually, yeah, technically, it is downwards. Nah, but anyway, so I'm heading back to LA on the 11th, and then I'm staying there until the 8th, 19th. Yes, 19th. And then on the 19th, I head to San Diego for a conference, and then I'll be back on the 22nd. So the long story short, I'm trying to say is from the 11th to the 22nd, streaming will be very, very sporadic. Yeah. Actually, so one thing I plan to do is I plan to record some video of the conference. No, man, I'm just there as a visitor. I'm not presenting or anything. I'm just there as a visitor. Um, but I'll take some video of the conference just to give people an idea of what it's like. I think it's allowed. At the very least, I can show it privately, right? I don't have to upload it to YouTube or anything. But yeah, so that's so I'll keep saying this until the 11th. But the streams will get kind of what do you call it? They'll be kind of they won't be there won't be any scheduled, or not that there won't be, but the streaming will be very arbitrary from the 11th to the 22nd. So just a preemptive heads up again. So yeah. But anyway, yeah. So yeah, thanks for coming by. Take care, stay safe, have a good evening, and I guess we're almost at the end of the week. So Asian cuisine. No, it's chill, man. It's chill. It's chill. Yeah, actually, I gotta find a hotel first for yeah. It's so much stuff to schedule for. But anyway, yeah. I'll try to update you guys with some. Well, I guess once I go to the conference, I can send some photos of what the conference is like. It's a biophysics conference, so it might not be super interesting, but anyway. Well, anyway, we can chat about the scheduling later. But anyway, yeah. So yeah, thanks for coming by. Take care, stay safe, have a good evening, and I'll see you guys later. お疲れ、おやすみ、終わり。